In this episode, we are going to consider the Gaussian elimination method. And this method is used to solve a system of linear equation using the matrix approach. So let's assume we are given some system of equation as, say, ax plus by plus cz equal to r1. This is our equation 1. And we also have dx plus ey plus fz equal to r2. This is our equation 2. And we have gx plus hy plus iz equal to r3, our equation 3. So we have this system of equations where we are to solve for the unknowns. When you check, the unknown variables are the x, the y, and the z. These are the unknowns, where the a, b, c, r1, d, e, f, r2, g, h, I, r3 are all known variables. Are you okay? So this equation is in the similitude of, say, 2x plus 4y plus 5z is equal to 6. This represents our equation 1. 6x plus 2y plus z equal to 1, our equation 2. And we have 4x minus 2y minus z equal to -6, our equation 3. So these are what we call system of what? Equation. We have 3 equations and we are to solve for the values of x, y, and z. Here we can use the matrix approach. And what method are we going to use? We are going to consider the Gaussian elimination method. So first of all, when you are given the equation this form, you are to represent it in a matrix form. And how do we do that? First, let's look at how to represent this part, the ABC part, in a matrix form. So here you are going to consider this formula A multiplying x equal to c. How we obtained this equations came from this part. So the A part represents the matrix here, and when you are writing the matrix, you are going to write the A, the B part, and the C part for the Z. The same thing for equation 2, that will be D, E, F, and for equation 3, we are going to get G, H, I. And multiplying the x is here is going to represent the unknown variables, and this is for our x, y, and z. So all those on the first row are for the x, and all those on the first column are for the x, second column is for the y, and the third column is for the z, this way. And our c is going to be the R1, R2, and R3 this way. So we know that from the multiplication of matrices, this is a 3 by 3 matrix, and this is a 3 by 1 matrix. We can multiply because the number of column is equal to the number of row, and our result is going to be a 3 by 1 matrix. And here we go, 3 rows, 1 column. So now we know how to write the matrix. The first thing is how to write the matrix from the system of equation. So let's look at this second part. We can write the matrix from these equations as we start from the first equation, that is going to be 2, 4, 5, and this is going to be 6, 2, 1. This is 4, -2, -1. Are you okay? And our unknowns are x, y, and z. Then the part is going to be equation 1 is equal to 6, equation 2, 1, and -6. Are we good? So now we know how to represent this part in a matrix form. How then do we solve this system of equation using matrix? So we are going to look at that. When you are given a system of equations and you are to solve using matrix, first you write the point. First you write the matrix form of the linear equation. So now you write the matrix from the equations. You have to be able to write your matrix from the equation, and we saw how to do it. The second one, we are going to use the method where you augment the matrix A by the C part. We know the C part. Are we okay? And now the third part is you try to convert the matrix and the augmented part to an upper triangular matrix. We will look at that. And the last part, I can say you solve the remaining matrix. This is simple. So, example, when we are given the equation, say 2y minus z equal to 4, our equation 1, and our equation 2, 2x minus y minus z equal to 5. Equation 3, 6x minus 2y minus 6z equal to 7. So these are system of equations, and first you write the matrix from the equations. So our matrix, let's say A from the equations, is going to be from equation 1, there's no x part, so that will be 0, the y part 2, the z -1. Equation 2, that will be 2, -1, -1. Equation 3, that will be 6, -2, and -6. This is our matrix from the system of what? Equations. Now we are going to use A by C. Now the C part, we know that the C part is going to be the 4. Equation 2, 5. Equation 3, the 7. Are we okay? This is a step-by-step approach to solve. And now we have matrix A, we have for the C. We have to, after merging them, you convert the matrix to an upper triangular matrix. So A argument with C, this form is going to be such like this is 0, 2, -1, 2, -1, -1, 6, -2, -2 by the C, which is 4, 5, and 7. So now we have it this way. And you remember something like this when we were trying to find the inverse of a 3 by 3 matrix using the row approach. So now that we have this, we try to convert the matrix to an upper triangular matrix. What do we mean by an upper triangular matrix? An upper triangular matrix is a matrix of the form, say we have 1, 0, 0, let's say A, B, 1, C, 0, 1. So this is an upper triangular matrix. It's a matrix that has 1s on the principal diagonal and 0 below the principal diagonal, and have other elements apart from 0 on the upper side. So this is an upper triangular matrix. Zeros down the principal diagonal, and you have to make sure that there are only ones on the principal diagonal, and the upper part can be any other number. Are we okay? So once you try the row approach, you apply the row approach to convert this part of the matrix to an upper triangular matrix, then you solve the remaining matrix. Very simple. Straight away, let's get an example and see how this Gaussian elimination is applied. Are we okay? So Let's say we are given some system of equations. Say given equation 1, 2x minus y plus 2z equal to 10. And we have equation 2x minus 2y plus z equals 8. And our equation 3 is going to be 3x minus y plus 2z equal to 11. And we are to solve this using the Gaussian elimination method. Pay attention to the method. So first, let's write our matrix from the equations. And our matrix, let's call it A. This matrix is going to be 2, negative 1. From here, 2. From the second equation, x is 1. The y is negative 2. And the z is 1. And from equation 3, we are going to have 3, negative 1, and 2. This is it. And the C part is going to be, now for equation 1, we have 10, equation 2, 8, equation 3, 11. This way. So now I'll move forward and find the A by the C this way. And this is going to be represented like this is 2, negative 1, 2. 1, negative 2, 1, 3, negative 1, 2, by the C, 10, 8, 11. Okay, so now I have it this way. I have to try and convert this matrix into an upper triangular matrix, which means everything on this principal diagonal is going to be 1, and everything below it is going to be 0. Are you okay? So that's how I can solve it. So let me try and change that. So before I can do that, here, can I swap row 1 and row 2? Yes, you have to do anything to convert it to that. So my first approach is going to be, I want to swap row 1 and row 2. And row 2. So swapping row 1 and row 2, that is going to be, so everything on row 2 is going to be on row 1. That is 1, negative 2, 1. Row 2 is coming to row 1, and that is 2, negative 1, 2. Row 3 is going to be the same, 3, negative 1, 2. And here we have 8, 10, 11. Okay, so I'm still in the process of converting it to an upper triangular matrix. I have 1 here, I have this, and I have that. And I have to turn the rest to 0. So I'm on it. Now, let's try to do something else to row 2. I want to convert this 2 to 0. I want to convert this 3 to 0. So what do? I have to apply certain equation. So I want to, for row 2, I want to multiply, I'm going to perform an operation on row 2 and row 3. So on row 2, I'm going to use this formula, 2 by row 1 minus row 2. And on row 3, I'm going to say 3 by row 1 minus row 3. So I'm performing two operations on this part. So meaning row 1 is not affected. It is going to be the same 1, negative 2, 1 by 8. Row 2 is going to be 2 times row 1 minus row 2. So 2 times row 1, which is 2 by 1, 2 minus this 2, that is 0. 2 by row 1, 2 by negative 2 minus 1, and that is going to give me negative 3. Now 2 by 1 and minus row 2, which is 2, that is also going to give me 0. 2 by 8 minus 10, and that is going to give me 6. On row 3, I said that is 3 by row 1 minus row 3. So here 3 by 1 minus 3, and that is 0. 3 by negative 2 minus negative 1, and that is going to give me negative 5. So when you work out, this is going to be 1 and this is going to be 13. Now I'm trying to turn it gradually. I want to obtain this as positive 1 such that everything on this row or this principal diagonal will be a positive number in terms of 1. So what do? I'll multiply 1/3 by row 2. So row 1 is going to be the same, 1 negative 2, 1. This is 8. Row 2, this is 0. When you multiply this 3 by 1/3, that is going to be positive 1. This is going to be 0. And this is going to be negative 2. Row 3 is going to remain the same, 1 and 13. So now I have this negative 5. I have to turn it to 0 in order to obey the upper triangular matrix. What do? I can multiply equation 2 by 5. So I can say 5 row 2 plus row 3. This will render this negative 5 to 0. Are we okay? So let's try and see. So the next row, I'm going to apply this to row 3, which says 5 by row 2 plus row 3. Row 1 is going to be the same, 1 negative 2, 1, 8, 0, 1, 0, negative 2. On row 3, 5 times row 2. So 5 by 0 plus 0, this is 0. 5 by 1 plus negative 5, and that is 0. 5 by 0 plus 1, and this is 1. 5 by negative 2 and plus 13, that is going to give us 3 this way. Are you okay? So now I have the final matrix this way. This is now an upper triangular matrix. Everything on the principal diagonal is 1. Everything below it is also 0. Are you okay? So now that we have it this way, how do we move forward to solve for our unknowns? Let's try and see. We have to calculate for the values of x and y. Now, so can we say the first row is our equation 1, the second row represents equation 2, and the third row represents equation 3. Are we okay? So here it is easy to now find the values of x, y, and z. When you consider from equation 3, if you were to write the equation from here, that is going to be 0x plus 0y plus z equal to 3. Are we okay? So since this is 0, 0, meaning from equation 3, our z is going to be 3. Now, from the second row, which is from equation 2, we are also going to write it as 0x plus y plus 0z is equal to negative 2. So since everything is 0, meaning our y is going to give us what? Negative 2. Now from the first row, which is our equation 1, we can write it as x minus 2y plus z equal to 8. Now when you put in the values of x or y and z, this is going to be our x is equal to 8 plus 2, and the value of y is 3. This is minus the value of z, which is minus 2, and our x is going to give us 1. Are you okay? Therefore, when you use the matrix to solve this system of equation, our x is going to be 1, our y is going to be negative 2, and our z is going to be positive 3. So this is the Gaussian elimination method. Very simple. Now you combine the matrix with the C part, which is this part, and you try to convert using the row approach the matrix to an upper triangular matrix. Once on the principal diagonal zeros down, then you can use this to solve for your, because every time this will be 1, you will be able to find the value of z straightforward, and this will be 0, you have 1 here, and if there is a value here that's for the z, you can put in the value of z and obtain it, and straightforward, you are good to go. Thank you for watching this episode. Kindly subscribe. Check out for the next episode for example 2.